Hey, folks, we're moving into chapter 8, which means we're really going to focus on more just straight algebra concepts. And I kind of like that. I know we all have some room to grow in algebra, and algebra is super important. But before we get to that, I want to tell you a little bit about myself. I do like to bake and make dinners and stuff like that. And one of my favorite dishes to make, it's not fancy, is called tater tot casserole. Some people would say, well, that's not really, healthy cooking, Nelson, but I love it. It tastes awesome. And if you've never had it, you're missing out. So here's what it looks like after it's done. It comes out of the oven, it's all crispy, and there's tater tots on top. And below it is ground beef and mixed with cream of mushroom soup. That I know it might not sound good, but that is really good. And then salt and pepper is in there. Maybe some other seasoning like celery salt. They don't have it in this recipe. And then cheese. Oh man, cheese on the top. You gotta have cheese. So this recipe that I looked up online, it feeds 4 people. Okay, so let's keep that in mind. I wonder, like, what questions do you have when you look at my pictures, or when you this is before it's been baked over here on the left. Um, when you hear my story about making tater tot casseroles, any thoughts come to mind when you look at this recipe over here? Well, here's a thought that came to my mind. Let's say we go to the grocery store and we see that packages of beef are sold just neat 1 pound tubes. You can't buy it as 1.5 pounds, or you can't buy it as 2.75 pounds, right? So they come as 1 pound packages. So I want to study, like, if I can get a certain amount of beef, like let's say I get 1 pound of beef, how much cheese am I going to need, right? So in this recipe, it says 1 pound. I need 2 cups of cheese. So this is, I guess we should probably put our units on here, pounds. And this over here is going to be cups, right? So if we have 1 pound of beef, we need 2 cups of cheese. If we double our recipe, like let's say we've got some friends coming over and we want to feed 8 people, okay? So now we need to double it, right? So we get 2 pounds of beef, then we would need 4 pounds of cheese. I mean, it's a super simple, I'm not trying to insult anybody's intelligence here, a super simple recipe, right? So we need a relationship between cheese and beef, right? So this one over here is called the dependent variable. This one's called the independent variable, the one that we're controlling. We go to the meat area first and we buy a pound of meat, or we buy 2 pounds or 3 pounds of beef. So this is the independent. Usually the independent is our X variable and cheese is our Y variable. So let's put a little note over that X, and then this is Y over here. Now you notice over here that independent and dependent isn't in my list of vocabulary. A lot of times in science, they use those words independent and dependent. In math, we sometimes use the word domain. This is our domain over here. So I'm going to put that in red. Our X value is our domain, and our Y value is our range. Okay, that's the numbers that come out after we decide, okay, we're going to do this much beef, right? So the Y is the range over here. So let's come over here and let's write a little definition. X is the domain. The domain is the numbers that we could put into our relationship. It's the numbers that we are choosing, the numbers that we're in control of, right? So usually it's the X values. All right. It's the ones that we control. We pick them, we control them, what we're going to stick into our function. And then the range is the values that are dependent upon the domain. So the range are the numbers, the Y values that come out of our function, the Y values, if you just want to break it down to that, it's the ones that get generated after we, choose our X value, right? So these numbers that get generated from the function, numbers that get generated from the function, generated from the function. All right, so let's dive into this a little bit more. All right, so what does it look like? We could choose 1, 2, 3, right? We could really choose any whole number for our domain. So let me just put down for, I guess, like if you're in a commercial kitchen, you could do, I don't know, 50 pounds of meat probably. I've never cooked in a commercial kitchen before, but in like your home kitchen, man, I don't know, 5 pounds of meat, that'd be a lot of meat. I don't know if I have a pan big enough to fry 5 pounds of meat in. I'd have to do it in batches, I guess. But in a commercial kitchen, man, they got huge stuff to, fry up 50 pounds of meat, no problem. So the domain could go, I theoretically it could go on forever. And we kind of need a way of writing that. So that's where set builder notation comes in. So if you didn't notice, I forgot to mention this in my notes today. You see, I've got little ones by it. In video one, I'm going to cover these things. In video two, I'm going to cover these. And then tomorrow, we'll talk about continuity. Okay, sorry, I forgot to mention that. So set builder notation comes into play. Like I want a way to show what values I'm sticking into my function. And it uses this little curly bracket. So what we could do over here is we could put down a curly bracket. And since I'm using my notes here, with respect to the recipe, I'm going to put also up in here in my domain. This is the beef. We stop at the meat department first and we pick out the beef. And then the range is the cheese, right? So let's put that maybe down here. This is the beef. This is the cheese, right? And so I suppose, like if we were going to try to write in set builder notation, we could put beef. And what could come out for beef? Well, usually they do this. They put a little vertical bar down. So beef is going to be such that that's what the little vertical bar means. X is positive integers. Okay. So then they put the little curly bracket and you might see it like that. Now let's look at the range over here, the cheese, right? So instead of the word beef here, they could have had domain, they could have had X, right? So now we're gonna study the cheese. Okay, so instead of putting the word cheese here, I'm gonna put down Y, and I'm gonna put a little vertical bar, and then I'm gonna say it looks to me like it's 2, 4, 6, 8. You put down some numbers to get a feeling for it. ... And it looks like those are the even numbers, doesn't it? Even positive integers. So you describe it, even positive integers. Okay. So this is really where set notation like this, I call it just set notation. That's what I've always seen in upper level math. Our book calls it set builder notation. That's why I got the word builder in here in parentheses. I've always seen like set builder notation handy when you have these kind of descriptions. So if we now go to let me compare it. We're going to compare right now to interval notation. If we go to the meat department and they say, you know what, we're not selling packages today. We just didn't have time to package them up as 1 pound packages. You can get whatever you want. So you could get 1.5 pounds of meat. You could get 2.5 pounds and so on and so on. Then interval notation might make more sense rather than set notation. So I'm changing the problem now. Let's change the domain, change domain so that it is all real positive numbers, all real positive numbers greater than 0. Okay, so I'm changing the domain right now, and the interval notation might be more handy. So here's what interval notation looks like. I'm going to put a parenthesis down because I don't think you could make the recipe without beef. You got to have beef. So it's got to be greater than, that's what the parenthesis means. I'm not going to take 0. If I wanted 0, then I would put a square bracket. So I'm going to compare these two. All right. So in a moment, I'll show you the difference between these two. So 0 to, gosh, I don't know, how far could we go here? Theoretically, you could go out to infinity, but I there is an infinite amount of beef on the planet. So at some point you say, well, what kind of kitchen are we cooking in? And maybe you set your domain to stop at like 10 pounds or something like that. Like I can't handle more than 10 pounds in my kitchen. Now I can handle 10 pounds. I could order 10 pounds. So now what we're saying is this is the same as in inequality notation between 0. Okay, so we're going to say, oh, shoot, I don't want the equal to. The equal to is going to come in right down here. 0 greater than or 0 is less than or equal to, because I got that square bracket. So the square bracket means equal to. Okay, equal to. And the parenthesis means not equal to. All right. So we're going to say 0. Okay. So X, we're talking about X here, right? And then it's got to be less than or equal to 10 because see how I'm stopping at 10? So you could do the same down here. You could say 10. So the only difference between this and this would be on the left side of the interval. We did not want 0 here because we're saying, well, we cannot make the recipe without beef. But let's say you're going vegetarian. You're like, hey, I can make it without beef. So you could go all the way down to 0 in that case, right? Now, you notice I had to change domain because this is saying all real numbers between 0 and 10, like 1.5 or 1.75 or 1.8, whatever comes out on the meat scale, that's what you take, right? So now we've talked about set builder notation, we've talked about interval notation, we've talked about range, but what the heck is this thing called codomain? In all honesty, in like pre-calculus and all that kind of stuff, I don't think we really deal with codomain. But here's the way that this author is defining codomain. Codomain is going to be the same as the domain unless somebody comes along and says something different about it. Okay, so the codomain here would be 1, 2, 3, 4. It would be the same as domain unless they specify, unless directly noted by the author. Okay. So I'm just going to say it's, the 1, 2, 3, 4, 5 numbers. Remember, it was let's see, where is the domain at listed again? The domain was, do we ever list it? Yeah, we listed it right here. The beef, X is the positive integers, right? And then here's the real rub that we're going to talk about next is the codomain the same as the range? So when we said 1, 2, 3, 4, 5, integers, is it the same as the range? It's not identical to the range. Okay. So that's going to impact these vocabularies that we're going to talk about in video 2. Okay. So thanks for setting up your notes and watching video 1 about domain and codomain. By the way, we're not going to talk about continuity and discrete graphs until tomorrow. We're just going to try to get this pretty healthy dose of vocabulary down today. All right. Thanks for watching.